Welcome to today's lesson. Today we are going to continue looking at solving equations. The questions we're looking at today have multiple steps of rearranging before we can solve the equation. Our first question today is x plus 5 all over 2 equals 17. Our method from previous lessons to solve equations is we first need to isolate the term and then we need to isolate the variable. The term that contains x is x plus 5 all over 2. This means it's already isolated. That means if x appears in the top of a fraction, we need to do something a bit different. So here we're going to isolate x by separating the numerator from the denominator. So we need to get rid of the divide by 2 in order to isolate the x plus 5. To get rid of the divide by 2, we need to do the opposite operation, and that is going to be multiplying by 2. We need to do that operation to every term in the equation, so we also need to multiply 17 by 2. I'm going to draw a line underneath this and then we'll carry out the calculations. X plus 5 divide by 2 times by 2, well, the divide by 2 and the times by 2 cancel each other out. This leaves us with x plus 5. The equal sign will drop down and then we need to do 17 times 2, which is 34. We've not solved this equation yet because we don't have the variable isolated by itself. So in order to isolate x, I now need to get rid of the plus 5. In order to get rid of the plus 5, we do the opposite operation, which means I need to subtract 5. When we're subtracting from an equation, we need to subtract 5 from both sides of the equation. So minus 5 is also going to go underneath 34. And if we draw a line underneath that, x will drop down by itself because there's nothing underneath it to change it. Plus 5 and take away 5 cancel each other out. The equal sign will drop down, and 34 take away 5 equals 29. So our final answer for this question is x equals 29. A reminder, we can check if our answer is right by replacing x with 29. So 29 add 5 is 34. 34 divided by 2 does equal 17. So 29 must be a correct answer. On to the next question. We have 2x minus 3 all over 5 equals 11. Again, because x is in the numerator of the fraction, I need to isolate that. So to get rid of the divide by 5, I need to do the opposite operation. Similar to the last question, this means I will multiply both of the sides, and we're multiplying by 5 this time because 5 was on the denominator of the fraction. 2x take away 3, divide by 5, times by 5. The 5's cancel each other out, leaving us with just the numerator, which is what we wanted. The equal sign drops down, and 11 times 5 is 55. Now we need to isolate the 2x term. This is the term that contains the variable. So now we need to get rid of minus 3. To do that, we need to add 3 to both sides of the equation. So 2x will drop down. Minus 3 and add 3 cancel each other out. The equal sign drops down, and 55 add 3 is 58. We're still not done because we don't have x equals a value. At the moment, we've got 2x equals a value, so we still need to isolate the variable. This means we need to get rid of the 2. This 2 is multiplying x, so the opposite operation would be dividing by 2. Dividing both sides by 2 is going to give us x equals 29. So our answer for this question, and again we can check it, is 29. 2 times 29 is 58. 58 take away 3 is 55. And 55 divided by 5 gives us 11. On to the third question, and we have the square root of x plus 7 equals 10. I can't jump straight into isolating x for this question because there is more than one operation going on. We're trying to add 7, but we're also trying to square root. So it's really important that I understand which order I need to undo these operations in. We want to isolate x, which means we actually want to isolate x plus 7 away from the square root. This means we need to do the opposite operation of square rooting. The opposite operation of square rooting is squaring. So I need to square the left-hand side of the equation, but that means I will also need to square the right-hand side of the equation. Squaring both sides means that the square root and the square will cancel each other out, leaving us with just x plus 7, which is what we were trying to isolate, and the equal sign drops down. Then we need to square 10. 10 times 10 is 100, so we end up with x plus 7 equals 100. We've got one more step to go. Because I need to isolate x by itself, I need to undo the plus 7, which means I am subtracting 7 from both sides of the equation. X again will drop down, plus 7 and minus 7 cancel, the equal sign drops down, and 100 take away 7 is 93. So our answer for this question is x equals 93. The next question is similar, except that there's going to be an extra step towards the end. We need to isolate the expression that's inside the square root first. So I need to try and get 5x minus 4 by itself, and then I will focus on getting x isolated. To do that, again, we need to square both sides. The square root and the square will cancel, leaving us with 5x minus 4. The equal sign drops down, and 6 squared is 36. Now I need to isolate the term that contains x, and that's 5x. So we need to get rid of minus 4. The opposite operation of minus 4 is adding 4. So adding 4 to both sides means that the 5x again will just drop down. Minus 4, add 4, cancel each other out. The equal sign drops down, and 36 add 4 equals 40. We've got one more step to go. To isolate the variable, that means I need to get rid of the multiply by 5. This means to both sides we will divide by 5. 5x divided by 5 is x. The equal sign drops down again, and 40 divided by 5 leaves us with 8. So the final answer for this question is 8. The next question is 2x squared add 5 equals 167. Because we have more than one term on the left-hand side, we want to isolate the term that contains the variable. This means our first step is isolating 2x squared by itself. To do that, we need to subtract 5 from both sides. And that will leave us with the 2x squared dropping down. Plus 5 and take away 5 cancel each other out. The equal sign drops down. And 167 take away 5 is 162. Our next step is potentially the trickiest part of this question. I still need to isolate the variable from 2x squared. We cannot just isolate x straight away because we need to understand which operation do we undo first. Do we get rid of the multiply by 2 or do we get rid of the square? What we do here is we need to isolate x squared by itself and get rid of the multiply by 2. The reason for this is, if we think about our order of operations, we would square x first and then we would multiply by 2. So when we're solving an equation, we're trying to undo those steps in the opposite order. So to get x squared by itself, we get rid of this 2 by dividing both sides by 2. This leaves us with just x squared because these 2's cancel each other out. The equal sign drops down, and 162 divided by 2 is 81. Now I'm feeling confident at this point because I know that 81 is a square number and the number I'm looking for gets squared to give me 81. We now need to isolate x, which means I now need to get rid of the square on x squared. To undo this, we need to square root both sides of the equation. The square root of x squared is just x, and the equal sign will drop down. And now we need to calculate the square root of 81. The square root of 81 is 9. However, there is a trick that we need to remember for this question. If we have an equation that says x squared equals a value, it's really important that we remember there's not just one answer for this question. There is another number that when we square it, we get the value of 81. The other answer that we need to remember is x equals minus 9. So our answers for this question are x equals 9 and x equals minus 9. On to today's final question, and here we have many steps, but if we follow our same rules, it's not difficult. We can see that we've got an x term in the top of a fraction. However, we also have terms that are outside the fraction. Here, this fraction counts as the first term, and this plus 5 counts as the second term. So because we have more than one term, we need to isolate the term that contains the variable. The term that contains x is the term that's a fraction. So we need to isolate the fraction by itself first. To do that, we need to subtract 5 from both sides of the equation. There's nothing underneath this fraction, so this entire fraction is going to drop down. Plus 5 take away 5 cancel each other out. The equal sign drops down, and 6.5 take away 5 is 1.5. We now need to isolate x out of the fraction. So we're going to isolate the numerator, that's 7x minus 5, away from the divide by 6. To get rid of the divide by 6, we multiply both sides of the equation by 6. 7x take away 5, divide by 6 times by 6, well the 6 are going to cancel each other out, leaving us with 7x take away 5. 1.5 times 6 is equal to 9. Notice as we go through the question, we are changing the equation into an easier equation that we feel more comfortable with. We're still not done. We need to isolate the term that contains x. So we need to isolate 7x. So the opposite of taking away 5 would be adding 5 to both sides of the equation. The 7x will drop down. The minus 5 and the 5 will cancel. The equal sign drops down. And 9 add 5 is 14. And we're nearly done. Now we need to isolate the variable itself, which is x, which means we need to get rid of the 7. So we divide both sides by 7. 7x divided by 7 is just x. The equal sign drops down. And 14 divided by 7 is equal to 2. Notice in this question, the algebra that we're isolating on each step gets less and less and less until we get to just x. So the final answer for this question is x equals 2. That concludes today's lesson on equations.